all right. Hello, good evening, namaskaram, vanakkam, shastriyakal, adab, to all the grade 12 students. This is your Ani ma'am back again with Trick 3 series. That's for your board examination. Already two tricks have been sent, and this is the third trick. We are doing the trick series in organic chemistry. As you all know, we'll be winding up the complete NCRT as mentioned line by line. Why Vani ma'am? Already 1.7k videos are done. Again, I'm revising for you all. That too, this is according to your board pattern which is prescribed by the CBSE for 23-24. As we know, we have 5 sections A, B, C, D, E. So we are going to drill till we become perfect. And one fine day, you need to send me messages saying that, yes, Vani ma'am, we have got 70 out of 70. That is how you have to do it. Perfect? Perfect. So let's start with the video, students. Let us not waste time. Let us be clear of what we are studying. Alright, students. Now, so the topic which I have picked up today is SN1 and SN2 reaction mechanism questions. I have almost done 20 different varieties of questions, which is almost covering 6 to 8 books. Yes, you've heard it right. So we are going to do SN1 and SN2 mechanism based questions. First of all, before I start, please understand I have done a clear video of SN1 and SN2 mechanism and everything is kept in the playlist. Today, I'm going to just give you the tricks what you have to remember before examination and quickly answer all the 20 questions and that too 20 different questions. Let's start. So before we start answering the question which is given, we have to remember 1, 2, 3, 4, 5 important points for the MCQs. If you remember these 5 important tricks, we are done with the questions. We can write or answer any question which is going to come. So the first question or the first factor which you should remember is SN1 and SN2 mechanism rate determining step. As the name suggests, because in the rate determining step, particular rate depends upon only one molecule, it is called SN1. And in the rate determining step, the particular rate depends upon the nucleophile and the alkyl halide, so it is SN2. Please go through the detailed video, again I am mentioning the same. Then you have to remember about the nature of alkyl halide, where there's a carbocation formation where tertiary stable than secondary then primary. But here there is no carbocation formation, there is only a transition state. So in this case, primary is more stable than secondary, then stable than tertiary. Go back to the mechanism where I've explained in detail and please just come back to the series to be easy for you all. After the alkyl group, you have to remember the nature of alkyl halide. Yes, the nature of leaving group. So whatever leaving group of the nucleophile which is coming and attacking, how should it be? The bond length should be more. When the bond length is more, I can easily break the bond and the one nucleophile can go and attack the alkyl halide. So wherever you see iodine is easier to break, right? The bond length is more, the bond dissociation energy also is less. So wherever iodine nucleophile is there, that is more preferred compared to bromine, chlorine and fluorine. Here in this case, we are going to again talk about the higher concentration of nucleophiles. So more the concentration of the nucleophiles as mentioned here, more would be the SN2 or more would be the formation of the SN2 product. Then comes the type of solvent. In case of SN1, I am going to use polar protic solvent. Polar protic is nothing where you have oxygen and hydrogen bonds. So polar protic solvents which like water, ethanol, acetic acid is what we are going to use for performing the reaction. Then in case of SN2, you are going to use polar aprotic solvents where there is no separately oxygen bond or the hydrogen bond. So in this case, I am going to take acetone, ethers, DMSO, dimethyl sulfonamide. In such way, we are going to pick up the polar aprotic solvents. And last but not the least, we are going to have SN2. There is a Walden inversion which is absurd. So basically, I am going to remember these 5 points and go to the exam. That's it. Those 5 points are precious. Now using that data, let us start with the MCQs. All the 20 MCQs, concept is the same. Let's start that. Let's see this question. What does it say? This says, which of the following alkyl halide undergo SN1 reaction more? SN1 reaction. They have given me 1, 2, 3, 4. What did they do? What is the difference? The difference is the alkyl halide. An important thing, they said SN1. According to SN1, what is the order? Tertiary, secondary and primary. In all the cases, tertiary, secondary, primary. For us, there is nothing to understand also. It is given quite common. What is differing? The one which is differing is a halogen atom. So as I said, Ci bond, in this case, the bond length is more. The bond dissociation energy is less. Obviously, I can break the bond and generate the nucleophile, right? So, which is easier according to this? Topic number 2, this particular tertiary alkyl halide with iodine is more preferred in SN1. Reason? Ci bond length is more. Bond dissociation energy is less. I can easily generate I minus nucleophile for that to go and attack the alkyl halide. Simple as that. Concept is easy. Let's go come and do one more question. Same concept. 5 concepts in my mind. Question is easy. Alright. Now first question is done. Table is there. Let us correlate the table with the second question. What does the question say? Here they have given me the complete reaction mechanism of which one. There is a transition state which is formed here. If you see, there is a transition state which is in square brackets. So transition state normally is observed in which one? SN1 or SN2? In SN2. So there is a transition state which is given where the nucleophile is attacking the alkyl halide and you are getting a formation of a transition state and then formation of product. Simple. They have labeled it as 1, 2, 3, 4 and 5. Let us read the question carefully and see what is the answer. They have given me which of the following statements are correct. It is not is correct. Which of the following statements are correct? Okay. They asked me, what is this? Let us see the first question. Given follows SN2 mechanism. This follows SN2 mechanism. Yes. Reason, there is a transition state formed which is for few seconds and then formation of product. So SN2 mechanism transition state. So this statement is correct. Next, 2 and 4 have opposite configuration. Okay. 2 and 4 have opposite configuration. 2 and 4, yes. In this case, H and H, there is a Walden inversion which is formed where the configuration is completely reverted. Where Walden inversion is there? In SN2. Second option is correct. Third, 2 and 4 have same configuration. Wrong, isn't it? 2 and 4, no. There is a complete Walden inversion, shift of the configuration. So 2 and 4 are not correct. Next comes, given follows SN1 mechanism. No. In SN1 mechanism, there is no formation of transition state. There is formation of only carbocation. The stable tertiary carbocation is formed. So, which two options are correct? Option A and option B. Easy peasy. Let's see one more question. Now, let's go and see the third question. Let's see the question. Which of the following or which of the given compound undergoes SN1 reaction faster? Simple. When they just give me SN1, go back, recollect that SN1 reaction, tertiary, secondary and primary. Done. That means in this case, in the first case, it's a cyclocompound. In this case, it's benzyl chloride. Perfect. Now understand. When this compound cleaves or because it's primary, we very well said, not primary, we very well said during the mechanism, there is a formation of carbocation. Correct? Yes. Now this cleaves, the bond breaks here. This also breaks here. When it breaks, this is going to form a benzyl carbocation. Correct? Na? It forms a benzyl carbocation. Done. Now here also it forms benzyl carbocation. But problem here is, in this benzyl carbocation, whatever is formed, further there is no resonance stabilization. Correct? Na? There is no resonance stabilization because there is no resonance concept only here. There are no pi bonds. But in this case, whatever benzyl carbocation forms, in this way, whatever benzyl carbocation forms here, that benzyl carbocation, it undergoes resonance. So because of this, this is resonance stabilized. So which one is more preferred? The carbocation which is more resonance stabilized is more preferred. So compared to this and this, which will undergo SN1? Yes. Benzyl chloride undergoes SN1 because of its resonance stabilization. Let's see the next question. Concept table are here only. Now let us see the next question. Let's see the question. A primary alkyl halide would prefer to undergo primary. They've given me direct question. Which is more preferred in SN2 mechanism? Primary is preferred. Easy peasy. Let us read this question. Arrange the compound in increasing order of reactivity of SN2 reaction. Again SN2. What are you observing in this question? As soon as they give me SN2, I have to fix in my mind that 1 degree is more preferred than 2 degree, more preferred than 3 degree. Then I have to also remember the order of nucleophile, that is I minus is more preferred than Br minus, more preferred than Cl minus, then F minus. Reason, as I said, more the steric hindrance part. Concept is like this. The rate of the reaction is inversely related to a steric hindrance. More the steric hindrance, the reaction will be less. So in case of primary, the steric hindrance is less, so it is preferred. Next, the reactivity is inversely related to bond dissociation energy. Bond dissociation energy is more, the reactivity is less. In which case the bond dissociation energy is more? In case of RF. I need, because the bond length is small, right? When the bond length is small, I require more energy to break the bond. So indirectly, if I have to tell you the order, I is first preferred, then comes Br, then Cl, then F. How should I arrange? I have to arrange in the increasing order of their reactivity. So that means the last one should be the highest degree of one preferred. The first one should be CH3F. Now CH3F is more ordered or less ordered. Should I write the bigger symbol? Should I write the smaller symbol? Always students get confused. Correct? So more bond dissociation energy, then CH3 Cl, then CH3 Br, then Cr. This is the order. Simple, simple. Let's answer the question. What is the decreasing order of reactivity in SN2 reaction of the following? Done. They have given me 3 questions. Correct? 1 bromo 2 methyl butane, 1 bromo 2 dimethyl propane, and 1 bromo pentane. They have given me 3 orders. I have to just tick which is correct. First of all, in SN2 mechanism, what is the order? The order is 1 degree is more preferred than 2 degree, more preferred than 3 degree. Perfect. Now elaborate these structures. What are there? Elaborate 1 bromo, it is 2 methyl butane. So let us write 1, 2, 3, 4. They said 1 bromo, okay, CH2Br. Then they said 2 methyl. This is also done. CH2, this is CH. Okay. Then 1 bromo, 2 dimethyl propane. 1, 2, 3. 1 bromo, okay, CH2Br. 2 dimethyl. There is a methyl group in the second carbon. This is done. Then the last one, they have given me 1 bromo pentane. 1, 2, 3, 4, 5. So this is your bromine atom. So let us write 1 bromo pentane. This is done. This is done. This is done. Now label it. The bromine is attached to a carbon having 2 hydrogens. This is 1 degree. Now the bromine is again attached to carbon having butane. They said dimethyl butane. Okay, 1, 2. The second one did okay. I left one more. CH2 Br. This should be here, right? This one should be here. Okay, this should be here. CH3, this is CH3. Then CH2, CH2. Okay. Second case, 1 bromo, 2 dimethyl propane only. I wrote it right only, right? Okay, sorry, students. I'll erase it. I'll redo it. 1 bromo, dimethyl propane. 1, 2, 3. CH3, CH3. 1 bromo. Okay, 1 bromo. Now in this case also, this is primary. Okay. Now here also this is primary. In all the cases it is primary. How will I decide? Now check carefully. According to the particular thing, I have written rate of the reaction is indirectly proportional to the bulkiness of the steric hindrance. Did I write that? Rate is inversely related to your steric hindrance. Perfect. Among all, which one is more sterically hindered? Means which one has more steric hindrance? The second one, B. B has more steric. So this is difficult. Then which is sterically hindered? Now see here 2 methyl groups. So there 2 methyl groups more steric hindrance. Now in this case 1 methyl group, 1 hydrogen little bit lesser. In this least preferred, least steric hindrance. That means according to me, C is more preferred because of less steric hindrance. Then A, less steric hindrance compared to B. B is minimum. That means rate of the reaction is inversely related to steric hindrance. More the steric hindrance, the rate is less. Concept is this. Let us see the next question. Question 7 and 8. Let's see. Here they are given arrange the following in increasing order of SN1. Alright. So both questions are given. Difference is there is a double bond. In few cases it is allylic, in few cases it is vinylic, in few cases it is tertiary, in few cases secondary. Tertiary is not given here, but secondary is given and primary also is given. So one thing to remember, answer I have already given. When such compounds like allylic, vinylic, tertiary, secondary is given, there is only one order for SN1. Remember, allylic is more preferred than tertiary, more preferred than secondary, then more preferred than primary. With that, if you remember, check which is allylic, which is vinylic and write the order. Simple question. So based on this order, I have given you the answer. Alright, now let's come and see the next question. Interesting question. Predict the order of reactivity of the following compounds in SN1. Alright, so SN1. According to SN1 order, what is preferred? Tertiary, secondary and primary. Perfect. Let us write the order. Tertiary, more preferred than secondary, then more preferred than primary. Similar, the nucleophile which is preferred is Ci or I minus, more preferred than Br minus, more preferred than Cl minus, more preferred than F minus. Correct? Now let us see. In all the cases, first of all, the compound which is, whenever you take a concept, clear. Once you understand the concept, it is easy for us to correlate everything. Order is given to me. In all the cases, here Cl, here Br, here this. I said something. The rate of the reaction is inversely related to steric hindrance. If the steric hindrance is more, the rate decreases. Now, you only tell me which one shall I pick up first. I'll pick up D because the steric hindrance is very, very less compared to everything. Correct? Then, I'm going to pick up A because bromine and iodine, like if I have to say, they asked me to arrange in the order, predict the order. They just asked me to predict the order. So, in that particular thing, I'm going to pick up A. Then comes B. Then comes C. Now, which one? This is less preferred, then less preferred, then less preferred. So, the maximum preferred is C. Why? Iodine, the larger group, easy to break the bond. Next, B. Bromine, easier to break the bond. Compare. Then A because bulky group, and then D. So easy for me to break the bond and form the carbocation and form the stabilized compound. Alright, let us see the question. In SN2 reaction, the correct order of reactivity of the following. They have given me A, B, C, D. Which is the correct order or which one is correct? A option, B option, C or D. Now I said SN2. Okay, SN2, what is the concept? Rate of the reaction is inversely related to steric hindrance. More the bulkier groups, the rate would be less. Lesser the bulkier groups, the rate would be more. So which here, halogen is not given, only the alkyl group. Now see, I have to check lesser steric hindrance group because the order is primary, secondary, tertiary. So lesser steric hindrance, here 1 carbon atom, here 2 carbon atoms, here 2, here 4. So I'll rule out this. More carbon atoms, more bulky means rate is less. Rule out this, rule out. Only this option. Let us see this is correct. Yes, this is more preferred because bulkiness is less. After 1 carbon, 2 carbons is preferred. After 2 carbons, 3 carbon is preferred. After that, 4 carbon. So the correct option is A option. Lesser the bulkier groups, more is the rate. Simple. Alright, so you would have understood by this time the concept of SN1, SN2. They'll be asking you based on the reactivity. They'll be asking you based on the solubility or the nature of solvent. They'll be asking you based on their intermediates. Nothing. Simple concept. So once again, thank you students for watching this video. I request all of you to please like the video. If you like the video, the visibility will be more. Please like the video, share the video, and I'll come back with more and more questions based on the stereochemistry of SN1 and SN2. Thank you so much for watching. Bye bye. Signing off.